So now we're going to walk you through how to graph a quadratic function in standard form. The advantage of this video is that you can stop and pause to catch up as much as you need or to rewatch a section if you get confused. So to successfully graph a quadratic function, we want to find 5 points. And depending on the function that's given, which form it's in, we're going to try to find different points. For standard form, one of the first points we want to find is the y-intercept. But let's first identify our coefficients. We're going to need them in a little bit. A is 2, B is -8, and C is 7. So to find the y-intercept, we are going to go back to our original function and we're going to substitute every place we have x, but we know the y-intercept is always at 0. So we're going to plug 0 in for x. This makes the equation or the calculation actually very easy because the zeros cancel out and all you're left with is 7. So the y-intercept is at 0, 7. So we're going to notice that the c value in our function, the term without an x, the constant value, is our y-intercept. So you don't always need to go through these steps. If you can just identify that it's in standard form, you can just take that c value. So we're going to plot that on our graph. That's the first step. So we got 1 point. So we're doing good. Let's go to the axis of symmetry. So the axis of symmetry, we need that a and b value. B is -8, a is 2, and we're going to plug that into our axis of symmetry formula. So we have -8, so those are going to cancel, and 2 times 2 in the denominator. So we do that, we get 8/4, or 2. So our axis of symmetry is at x equals 2. So we're going to put a vertical line at 2. Again, stop this anytime you need to catch up. And you want to make sure you're writing small because we have a couple more calculations to go. So the advantage of the axis of symmetry is it allows us to reflect points from one side to the other so that if we found this y-intercept, we can reflect it to the other side because we know it's 2 units away from the axis of symmetry, so we can make another dot or point 2 units away. So that's going to help us to maximize or to minimize our calculations. So we have our y-intercept and we have a reflected point. So we need to find 3 more points. So the next point we want to find is the vertex. The vertex is always on the axis of symmetry, and this is probably the thing students struggle with the most in this for this calculation, is knowing like what to do. So we know that there's a point on that line, and that line x is 2. So we're going to substitute 2 into our function and figure out what the y value of the vertex is. So when we plug 2 in there, we get 2 squared times 2. Again, remember the exponents come first. So that gives us 4 times 2. The middle term, we get -8 times 2. That's -16. And we get 7. And then we get 8 minus 16 plus 7. And we get -8 plus 7 is -1. So when we put 2 into our function, we get -1 out. So that is our vertex, 2, -1. Again, we plugged in 2. We picked 2 specifically because it's the axis of symmetry. So we're going to plot that vertex down here. So there's 2, -1. So now we have 3 points. So we need to find 1 additional point. You have some freedom to pick whatever point you want. However, keep in mind, the further you get from the axis of symmetry, the further the y value is going to be from your window. So we want to try to pick something tight and up close, but we already have something at 0. We already have something at 4. So we should pick at 1 or 3. Now, here's the thing. 1 and 3 are actually going to be the same points because they're going to be symmetric. So I'm just going to pick 1, and the reason why I pick 1 is an easier number to work with. All right, so I'm going to plug 1 in because I want to figure out what the point of the parabola is. This is where you start to need to think about what it should look like. If I have 2 points here, and my vertex, the lowest point on this graph, this is the minimum, is down here. I know my point has to be somewhere between 7 and -1. So when I do my calculation, I need to check for reasonableness. All right, let's plug 1 in. 1 squared is 1 times 2. That's our first term. -8 times 1 is -8, and 7. So you can see why picking 1 is advantageous. So then we get 2 minus 8 plus 7. and 2 minus 8 is -6, plus 7 is 1. So at 1, when we put 1 in for x, we get 1 out. Again, use Desmos Scientific Calculator to help you with these calculations. Just make sure you use parentheses around the x's. All right, so our additional point is at 1 comma 1. So we're going to put that on our graph. So 1 comma 1 is right there. And we're going to, again, reflect our graph, reflect our point on the other side. We're 1 unit away, so we're going to put a dot 1 unit away. There is our 4 points that we need to put for our quadratic function. So we're going to connect them together. Remember, it's a curve. There shouldn't be like a sharp point on this. This opens up, and we have a minimum. Our vertex would be a minimum. The last thing we need to answer is our domain and range. Our domain, this graph goes to the left forever and goes to the right forever. So our domain is all real numbers, and it will be always. Our range is going to be, if we notice that our graph goes up forever, but it stops here at -1. So it's y is greater than or equal to -1. We have to use the equal to part because you can be at -1. We didn't use the equal to, if you remember, when we were doing exponential functions. So there's a lot of stuff here, but keep in mind, if you know what points you're looking for, it'll drive you in your calculations. The last thing you should do is to practice another one. Go to the extra graph section and practice on x squared minus 2x minus 8. Use your notes to help you. But again, rewind this video if you need to.